So hi everyone, let's read this question first. Two spherical bodies of same material having radii 0.2 meter, 0.8 meter are placed in the same atmosphere. So there are two spherical bodies here. One spherical body having the radius 0.2 meter, one more spherical bodies having the radii 0.8 meter are placed in the same atmosphere, means same environment. They are placed in the same environment, okay, like this. The temperature of the smaller body is 800 Kelvin. Here 800 Kelvin. Its temperature. Its temperature of bigger body is 400 Kelvin. If the energy radiated from the smaller body is E. So here rate of emission is E. The energy radiated from the bigger body is. Assume the effect of surrounding is negligible. There is no effect of surrounding here. Effect of surrounding be negligible. So we know that rate of emission is what? Rate of emission is dq by dt is equal to E sigma A e to the power 4. E is what? Emissivity. Sigma Stephen constant. Here same material. Already we have mentioned that same material. E is same. Sigma Stephen constant is same. And dq by dt is actually the power or energy radiated per second. That is power radiated here. So you can say it is power. Here energy radiated dq by dt. And what is A? A is the surface area. Here surface area for sphere is 4 pi r square. So now this question is very easy. You can easily solve and give me the answer fast. If you can just stop this video and give me the answer. dq by dt for smaller body small is equal to the area pi r 4 pi r square. So r is like this. Rest of the things are constant, so I'm not confusing. Temperature of small body is 800 Kelvin divided by dq by dt of larger body large or big. Okay, it's 0.8 whole square multiply 400 Kelvin. So this is given like how much E. They're asking for larger body G radiated. Yeah. Larger or big body. Solve will be 1. So correct answer is option 2. So rate of emission or energy radiated from the bigger body dq by dt from the body. Okay. I think this doubt is clear so much.